good. Okay, I've got a lot to do today, tonight, whatever you want to call it. And going to get started. Essentially, we've got 3 sections to cover because this week is a one-day week, but we have to cram in what we can. And this is a totally new section. It involves what are called radicals. And there are 3 sections, 7.1, 7.2, and 7.3. So I think what I'm going to do is just do each section, have a break at the end of each, kind of natural place to stop. And then when you come back, we'll do 7.2 and have another break. And then we'll batter through 7.3 and we should get that finished before the end. There's a lot to take in. There are a lot of questions. And before you get too concerned, there are a lot of very quick questions. So if you look at them, they're like, some of them are ridiculously simple, but it's just to get you into the idea. And then they get progressively worse or more interesting. Depends on your viewpoint. So let's look at my first one, the one we're going to do first, and that's in chapter 7.1. And it's the heading of that chapter is radical expressions. Okay, let's start right at the beginning as if you've never seen one before. What is a radical? It's a pretty good question to start with. Rational is just an old-fashioned name for fractions. Radical is a term that we use for things like square root, cube root, fourth root. So for instance, an example of a radical would be the square root of 25, the square root of 16, square root of 1. They're all examples of radicals. But you can also do things called cube roots, and you put a little baby 3 on them when you do them. So these are square roots. So normally when you say this loud, you say the square root of 25, the square root of 16, the square root of 1. This would be the cube root of 8. This would be the fourth root of, we'll pick something interesting, 81. And you might even get as high as things like the fifth root. That's a bit hard to do, so I'll keep it small, 2, 4, 8, 16, 32. So that's what they look like. If you're still not sure what they are, the square root of 25 is the number 5. What you're looking for when you find the square root of 25 is a number that when you square it, you get 25. And that is pretty straightforward. Agreed? So let's do some practice. I've done that one. A lot of these you can do in your head, and if you can't think of an answer, you can do the trial and guess. I think it might be 4, I think it might be 5, I think it might be 6, although you probably could guess if it was 5. What's the square root of 16? Nice baby question to get started.
4.
Yeah. And what's the check? The check is 4 times 4, 16. That's easy check, isn't it? I'm doing that one because that's probably the only one I'm going to get right tonight. Now, cube roots. Well, the cube root of 8 is in fact the number 2. And what does a cube root look like? Well, the cube root is a number that when you cube it, cube it means you multiply it by itself and then by itself again. So you do it like 3 times in a row. So when you cube it, oops, I've changed pens here. You get 2. So it's easy to check. Well, maybe not easy, but it's straightforward to check. Isn't the cube root of 8 2? Because 2 times 2 times 2 gets you 8. I keep jumping around with my different colour pens. Hopefully I got this one right. I'm not going to go fourth root and fifth root. You can guess how they're going to be the same kind of story, right? I'm looking for the fourth root of 81. So I'm looking for a number like 2 or 3 or 4 or 5, whatever it is, that when you go the number times itself, times itself, times itself, you get 81. Anybody got a clue about that one?
3.
Yeah. And wouldn't the check be 3 times 3 times 3 times 3 got me 81? That's basically how you do this. What about the fifth root of 32? Fifth root of 32. Some number times itself, times itself, times itself, times itself gets you 32. Who on earth is that guy? No takers? Okay, here it goes. Oh, well done. You got in before I said that. 2. And wouldn't the check be 2 times 2 times 2, that's 3 of them, times 2 times 2, that makes 5 of them. And if that equals 32, then isn't the cube root of 32 2? Now, right now, we are doing square roots and cube roots. We are doing radicals, right? They're all radicals of nice numbers that give you relatively easy answers, right? I haven't asked you for the square root of 72 because you'd have a really hard time doing that because it's not even a whole number, right? It's some weird decimal and things like that. Right. So here's another question to do with radicals. In fact, to do with square roots. When is a square root not a real number? Because some of the questions you get in the homework is find the square root or cube root, whatever it is, and if it's not real, say so. So let me show you an example of a square root that is not real. The square root of -9 is not real. And you can kind of check it. If it was going to exist, would you agree the number would have to be some kind of 3, right? It would have to be something to do with 3, because 3 times 3 gets you 9. Isn't that the only way you're going to get 9? Well, let's see what happens to the two choices. If I take 3 and you multiply it by 3, I don't get -9, I get 9. Well, I guess the other choice would be maybe I would go -3 times -3. And you can't mix and match. If you pick a number, you've got to use it all the time. But what does -3 times -3 get us? It also gets us 9. So we would say that this fella is not real. There must be an easy way of doing this. Is the square root of -16 not real?
It's not real.
Good. What's the short way of just knowing without doing really any calculations? There's something about this and this that makes them not real. That's what it is, isn't it? If this thing inside the square root is negative, won't the answer be it's not real? So can you imagine if you've got lots of questions, how quick some of these questions are going to be? If you get this one, isn't the answer in the box just going to be 5 and it's done? If it's this question here, won't the answer be the words not real and then you're finished? Now I'm going to do a question that might look not real, but it is real. In other words, it's a number. I'm putting a negative there and sticking the 9 there. Now, if you figure out what that is, can you see that this negative on the outside is not the same effect as putting it inside the square root? Technically, isn't the square root of 93, and if you stick a negative in front of it, do you see that's how you could get -3 out of one of these calculations? That negative is not inside the square root. Therefore, you get this answer. What about that?
Not real.
Correct. What about this negative? Well, that's what makes it not real. See, if something's not real, sticking a negative in front of it just means it's a negative thing that's still not real, right? So it's still not real. Does that make sense? You might think that this negative kind of cancels out that negative and the answer's 2, but it doesn't work that way. They don't cancel each other. A negative inside the square root does not miraculously disappear because there's another negative somewhere else in the expression. They don't work that way. That's kind of not how things work. So do we feel comfortable that if I gave you a square root of a number, you could, if it was a nice number, you could do it in your head, and if it was not real, you would know when it was not real? Does that seem reasonable so far? With nice numbers. If you hold on a second, I'm wondering what I'm going to do with my dogs. Should I give them away to the circus? No? You're probably right. Now, this is bad behavior. Do not do this with your kids. I'm going to give them a treat to shut them up, because my wife is out right now because she would be dealing with this. But you know what happens if you give treats to bad behavior? You encourage it, right? So if your kids run about screaming a lot and you give them a piece of candy to shut them up, won't they end up screaming a lot more the next time so you can get more candy, right? My dogs have went quiet. Let's just keep going. Maybe they've got fed up looking for attention. So back to what I was saying, you're comfortable with the square roots of numbers, and I got a few nods, so I'll move on. So let's do some cube roots. Well, I'll start off with a cube root of something that's kind of big. Can you trust me that the answer to that cube root is 10? And if you're any good at your calculator, you know, for this type of question, can't you let your calculator do most of the work if it gets really ugly and really big? No. So if somebody says the square root of 144, you know there's a square root button in your calculator and you'll find out the answer's 12. But you know, if you can do it in your head, it's even quicker. Now, this is a trick question. I am warning you up front. This is a trick question. Is this guy real or not real?
Real.
You didn't fall for it. Well done. What is the numerical answer? What's that equal to?
-10.
Now let's do a check. If this is true, and it is, right? It isn't a non-real situation, right? It does have an answer that's a number, it just happens to be a negative number. If this is true, shouldn't I be able to do this guy times this guy times this guy, and shouldn't it equal -1,000? So let's do my check. -10 times another -10 times a third -10. Right, can you imagine 10, 10, 10? That's where the 1,000 bit comes from. Now, a negative number times another negative number is positive, but if in turn you do another third negative, don't you get a negative out of that calculation? Negative times negative times negative. So we have got it. Now, that makes the rule about am I real or not quite easy for cube roots, because isn't the answer is they're always real. They're always going to get you a number of some kind. Even if it's a weird number, you can always do it. And if you're really good at your calculator, you can actually get it to do those as well, but that's something you're going to have to learn on your own. So every cube root is real, essentially, right? So you're never going to say not real. Well, we do most of our work on square roots and cube roots because that's the most likely things that happen in science questions and formulas and so on, right? There's a fair old number of formulas with square roots in it or cube roots. But for completeness sake, let's do a fourth root. You know, like the fourth root of 81. And I'm just going to use that number because it's handy. Is the fourth root of negative 81 real or not real?
Not real.
Agreed. Now, it could be a guess. I'm assuming it's not. So do you want to volunteer why you decided that? Because it is right.
Because it looks like if it's even, it's always going to be not real. But if it's an odd number, then it's going to be real.
Oh. I like your explanation, so I'm not going to say any more than what she just said is exactly what's true. Right? I would just confuse it if I added to you. So if you get stuck in that, watch this video, and when Mary comes to that bit, oh yeah, I got what she's saying. Real or not real? Real or not real?
Not real.
Wasn't her description of how you can tell pretty concise? What about fifth roots in? And I need a number. I'll stick in a negative, of course. And I want a number like negative, I don't know, 3, 9. Just tell me if it's real or not real. You don't need to figure out the number because it's pretty hard to do in your head.
Real.
Real.
Agreed? The answer happens to be negative 3 because I kind of did it with my fingers. You know your fingers are really good for these questions because you go 3 times 3 times 3 times 3 times 3 and you keep track of it and it works. So where are we right now? So we've seen what radicals are. I think we're comfortable now about getting the answer to square roots, cube roots, fourth roots, and fifth roots. We're comfortable about when something is not real and when it is real. We got that kind of sussed out in our head. We feel good about that. So, you know, if I said this, you would know it was not real. If I said this, you knew it would be real, and then eventually you'd figure out what the missing number is. All looking good. Can we move on to the next piece of this work then? You feel good about this? You're allowed to shake your head or, I don't know, do something. Move, that would be good.
Yeah, it seems pretty easy.
Oh, thank you. Yeah. Right, so we're going to do radicals with variables inside them. If I asked you to get the square root of 9, you would say 3, and you would be perfectly correct. If I asked you to find the square root of 9x squared, that's a little bit different. It does simplify, right? It does change into something a little bit nicer looking. If you want to separate the thing, it's basically the square root of that with the square root of that next door. Now I know what the square root of 9 is, isn't it? 3. What do you think the square root of x squared is?
X.
What's x times x? X squared. See, it works. But you'll find that they want that funny little vertical line. Can anybody remember what that vertical pair of lines means?
Absolute value.
Right. Why is that there, you might think? Are they being a bit fussy? Well, I guess they are being a bit fussy, but they're doing it for a good reason. Do you know that when you get a square root of something, shouldn't this always be positive? I mean, square root of 8 or 25 or 70 or whatever the number is, it's always a positive number. If you didn't have this absolute value around it, you could, in certain circumstances, falsely think that the answer was just x. And I know it's been a bit fussy, but can you imagine that instead of x squared, it was 9 times negative 2 squared? Right. Don't get worried about that negative, because isn't that the same thing as 9 times 4? And isn't that the square root, well, I guess, of 36? which we all know is 6, right? But if I use this gets me 3 and this gets me x, can you see if I just used the number, right, that's like the x, couldn't I falsely think that the answer was -6? So that's just the reason. You stick an absolute value around it and it just makes everything positive. So once you've done 2 or 3 of them, you won't even know that you're doing it because you just say, oh, that's a rule, you keep everybody in math happy. So what would the square root of 25b squared get us? Well, I've seen somebody's lips moving, so I did catch a 5, but I don't think I heard, because you never said
Absolute
it.
value of b.
All right. Are we cool with the square root thing, right? Let's up the ante. Now, this is a trick question. I'm warning you right up front, it's a trick question. 36x to the 4, right? The square root of 36x to the 4. Anybody want to go for it and not get caught by the trick? Right, we should all be able to tell me the number, agreed? So go for the number. If that's all you want to tell me, I'll take it. What's the number?
6.
Okay, now we have to figure out what that guy's going to get us, right? So what's the square root of x to the 4?
x2.
Agreed. Now, that does not need an absolute value around it. That did, this didn't. And you might say, well, why doesn't this need it? Remember, the only reason that's there to make this positive, isn't x squared always positive no matter what value x is? Now you might say that's going to be a bit messy. Well, I'll tell you, yeah, it will be a bit messy, because if you type that into the WebAssign, do you know they might kick you out and say it's wrong? Because you gave it something it didn't need, right? So it's just a little rule you got to get used to, right? That you stick absolute value around those terms that need them, right? And you don't bother with it when they don't need it. What would the square root of 100, I'm running short of x's to do here, x to the 6 get you? And this is probably at the extreme end of this. Square root, I'm doing that bit, 10. What about x to the 6? What do you get when you do the square root of x to the power of 6?
x3.
Now here's the question. Only one of these is right. You need it for x. You don't need it for x squared. Do you need the absolute value for x cubed when it happens? Yes. Because think of x being -1. If you're not sure, just pretend that x is -1. If I plug -1 in here, won't I get the answer -10? And all square roots are positive, so that's not going to work, right? All square roots are positive. So there's your answer. Are we good? Right, let's try doing the same process, but with cube roots. Square roots are a bit of a pain because of the rule about when you do and when you don't need absolute values. I wonder if cube roots cause the same problem. So let's do the cube root of 8x cubed. Okay. The cube root of 8 is a nice number, so I'll do that bit. The cube root of x cubed.
X.
Now, here's your question. Do you need an absolute value in this question when it's cube roots? Not sure? You don't. And why don't you? Square roots have to be positive, right? Just the way that they work. Square roots, fourth roots, sixth roots, right? They must be positive. That's why they have the absolute value thing going on. But can cube roots be negative answers? Well, yeah. Do you know the cube root of -8 is -2? So if it's okay to be negative, you don't do anything. So you've got this funny little dichotomy of, although you're doing the same kind of thing, the rules about what you write and what you don't write change. Excuse me. What's up? Okay. Okay, that's our got our treat. That should last about 4 minutes. So we were talking about cube roots, right? So when you're square roots, you have to worry about the absolute value. When you're fourth and sixth roots, you do. If it's a cube root or a fifth root, you don't. Kind of takes us by that issue. So, well, it didn't last more than a few moments. How about back to some numbers? How to find square roots of fractions, like 2536. Well, what you do is that you're allowed to split the square root amongst the two parts. So the square root of 2536 can be split into the square root of the top over the square root of the bottom. And when you do it that way, you got your answer. Does that seem reasonable as far as square roots go? I mean, as a process, it doesn't seem too weird. What about the cube root then of 8 on the top and 125 on the bottom? Well, cube roots follow that same trick. Cube root at the top, cube root at the bottom. Oh, I'll do 8. Okay, volunteers, cube root of 125.
5.
Yeah. Now, since I've got this question in front of me, suppose this was a negative cube root. So it was negative 8 over 125. Couldn't I basically just stick the negative there and they'd be finished? Negative cube roots just give you a negative answer. So if you see a negative inside the cube root, pretty much ignore it and then just remember to stick it at the end and you'll be fine. On the other hand, what would a negative square root of 2536 get you? It would get you a not real again, wouldn't it? Because it's a negative number. Any kind of negative number kills it. And good. What about this fraction? Square root of 1 over 49. Any takers? Square root of 1 over 49.
1 over 7. Yeah, 1 over 7.
I agree. Suppose the negative was on the outside, because sometimes it might be. Wouldn't the answer just be negative 1 over 7? Because it's okay to be outside, it's inside that causes trouble. I think this is going pretty well. At least I'm not seeing too many scared faces. Are we doing good, Brittany? Hello, Brittany. You with us?
Yes.
Are we doing good? We're doing good. Okay. So I am going to give you a bunch of square roots and cube roots and fourth roots, and just to kind of finish this bit off, and then we'll go and look at some of the homework questions. And once we've done that, we should be finished our first section. We can have a wee break. So, in no particular order, Let's see what we're going to get. All these questions are going to be find the value, or if it doesn't exist, say not real, right? So that's what all these various questions are going to look like. So. Okay, I'm going to see if I can make my dogs behave. Both my dogs are here, so any moment now he's going to start barking. And as soon as my wife returns, I'm going to give her both the dogs. Let her, I don't know, take them next door and give them away, something like that probably. I didn't give you a time. How good are we with these? Do you need any more time? You zoom through them that quick? They're pretty fast to do. So can you imagine you had 30 questions like this? It might look horrible, which it will, but it won't take you that much time. Okay, I'll give you the last few seconds. Okay, I'm going to pick a victim for each question. That way I won't have these long, awkward pauses where eventually someone just answers to shut me up. So, Erica, you're on. You're watching, Erica? Number 1, what's your answer? You've got to hit the space bar.
That was one I was confused about. I have all the other answers.
Okay, let's do it
The
with you then.
4.
Right, it's a fourth root, right? And fourth roots behave just like square roots. So if I said to you, what's the square root of -8? The answer would be not real. Hopefully you all got that one. Okay, cube root of -8. You want to do that one? Cube root of -8, Erica.
-2.
You got it? Okay, who are we going to pick as our next victim? Maddie, you're getting the next one. What's this fella?
2 of the absolute value of x squared.
Now here's interesting. Do you need an absolute value when it's an
No.
x squared?
Nope.
Yeah, it's not that you're wrong. To be honest, you're not really wrong. In fact, I don't know. In a perfect world, nobody would take any points at all off you. But Weber's sign isn't very friendly. So you might actually do it correct and then wonder why on earth it's not, you know, because it is, for all intents and purposes, right? It is the same thing. Okay, Carliana, you got the next one.
3x to the 3rd.
Right. Do you need any absolute values around this one? Correct. Okay, Brittany, looks you're getting the square root of the fraction then. You got it?
Two over 5.
Pretty cool, right? Not too painful. I'll take a volunteer for the last one.
-2/10.
And I totally agree with you, but that's not going to be the answer. It's correct, but it's not the answer.
-1/5.
Hasn't happened yet, and I'm glad I chucked that one in. I didn't realise I chucked it in until too late. If it's a number, it should be simplified. At least if it's a fraction, it should be simplified, right? For the obvious reasons. Okay, so what we're going to do now is we're going to zoom over to our homework. I think I've got the page set up. It's here. And which one? That's not the one. That's the third one. I got the second one yet. And we have it. Okay. So why on earth didn't I get it the first time? Where are you hiding? Oh, here you are. Right, there are 30 questions here, which I have warned you about. And let's kick off those answers, because that definitely would distract the heck out of us. Can you see his base? Go away. Answers. Go away. There we go. Up and down, go away. Whew. Okay. Evaluate the square root of 81. And if it's not real, type in capitals, not real. Would you agree this answer is 9? And we're done. Well, that wasn't even 10 seconds, was it? Right. Would you be happy about getting the square root of 196? At least you've got a choice now. It's definitely real. Would you agree it's a number? So it has to be one of the other 4. Any volunteers for which one it is?
14.
Yeah. Was that a guess, or how did you figure it out? Because that was right.
I did the math.
You just did 14, 14 in your head? Oh, you have a young
Well,
brain.
I did 12 and 12 and then went up from there.
Okay, so 12 times 12 is 144, so the next one was the only one left. Nothing wrong with that, it's a good strategy. That guy is easy to do. Would you give this guy is easy to do? This one is easy to do. Right. I'm trying to find one that might not be, well, I can't say not easy to do. Right, there's one of those fraction ones I talked about, right? So if you click on the box, oh, it doesn't work with me. But when you click on the box, don't you get over on the right-hand side the little thing so you can type in fractions?
No.
So you don't get that?
I don't think I did.
Well, I don't get it because of, the weird way my thing works, but you do, I'm sure.
Sometimes I do and sometimes I don't. This time I don't.
I just did the number and then a slash and then the number again.
Okay, so
numerator
/5.
denominator. Yeah, and it worked.
Yeah, so it works. Okay. That's frustrating. Shouldn't it really do in the same kind of question, it should do the same kind of box for everybody, right? That's just annoying. So wish I could do that one for you. Oh, I didn't do a decimal. But it is a number. Any guesses? Square root of
0.7.
yeah. Can you just do it in your calculator? Square root of 0.49, it'll tell you. It's a nice answer, right? What about 10? Which is right at the top here. Square root of -49. What do you
Not
write in the
real.
box? It's
Not a
not
number.
real. Yep, not real. In 11, not real. Does this negative on the outside of the square root help question 12, or is it still not real?
Still not real.
Still not real. In fact, didn't we do one kind of like that today ourselves? Okay. Good grief. I do not know what the square root of 280 is, but evidently it's a number, so good luck. I don't know what the square root of 430 is, but the fact they're asking me to give the answer to 4 decimal places, isn't that a clue that you'll have to do your calculator? And so since I've got my calculator handy here, I'll just tell you what that one is. I'm doing a square root button, which is, in my case, the blue square button, and I'm typing in 430. And the answer I'm getting is 20.7364 and some stuff. Now that number that I didn't know in my head, the square root of 289, the answer to that, believe it, well, I've got it now, so I can ask it. What is the square root of 289? Any takers?
17.
Yeah, you probably had to do what I had to do, right? Calculator. Right, then we enter into the world of square roots of 9x squared. Now, if you were doing this, good. You see over here, the little thing that I was wanting to appear all the time, I've actually got one now. You see this guy here? The answer is definitely 3, but now I need an absolute value. So let's see what we got. If I hit functions, do you see that fella there? Boom. And then I type in x. Do you see how I got the absolute value? It's on the functions, hit that button. So that's where it was hiding. And that is the answer to that one. The multiple choice are a little bit easier because basically you pick the one that works, right?
I had a question.
Yes.
So if we needed to do that x, then what if it needs like x cubed or?
Oh, okay. Let's pretend, I'll have to go back to this question, right? Let's pretend that it needed an x cubed, right? Just because it's a different question, right? So I'll get this out of the way. I hit the function and I pick that guy. I then type in x, and then I would go to operations and hit this button and put a 3 in. So it's in 2 different submenus, right? The absolute value is in the function submenu, and this button here is how you put squares and cubes and all the other good stuff there.
So for that equation, you only needed 1x. So then,
Yeah, so in this case, it would just be 3 absolute x. But I'm putting that one in because you were saying, you know, how would you do?
yeah.
How would you write it in if there was a need for an x cubed, and that's how you would do it. I think these guys here are really just plenty of practice at doing the same thing. Okay, I might not have done one as big as that, but we're already well on our way to doing all these questions. So what would the number part of 22 be? So 121, what's the square root of 121?
11.
Okay, so you put 11 in. What was the square root of m to the power of 8? What power of m would you get if you took the square root of m to the power of 8?
2.
Not 2. Keep thinking.
4.
I saw someone's lips move and it was the right number.
4.
4. There's a simple rule for figuring out what square roots do. Don't square roots half the power of the original. Right, so if the thing inside the square root was x to the 4, wouldn't you get an x squared out of it? If it was x to the 6, wouldn't you get an x cubed out of it? If it was t to the power of 10, wouldn't you get half that power, t to the power of 5 out of it? Because essentially, doesn't square roots split the power into 2 equal halves? Well, if you want to take 8, right, m to the 8, and you split it, don't you have to call it m to the 4, m to the 4, right? That's the split, half the power. And we have reached a point where I need to come back out and we need to do some examples I haven't covered yet. You ever seen those horror movies? You might wonder where this conversation's going. You ever seen those horror movies where they kill Dracula or the swamp monster or whatever it is? And at the end of the movie, you think everything's safe, and then you find out that Dracula wasn't really dead or the swamp monster came back to life and you're in trouble. Right? So if you thought that factoring had left the building. You did it in that last section. I don't need to worry about it again. It's dead. Can I tell you that the swamp monster has arrived? You're going to have to factor again. So, the square root of x squared plus 8x plus 16. And we're going to have to simplify that. And the way that we are going to simplify it is by factoring this guy. So I'll do this over here like my side work. Okay. Isn't this a simple trinomial, right? So it's going to be an x here and an x here. Aren't we looking for two numbers that multiply together that give me 16? But when I add them together, I get 8.
4.
Agreed? Now, isn't there another way that you can write that? When the same factor is being used, can't you call it x plus 4 squared? So back to this. This guy is now going to be called x plus 4 squared. Ah, there's method to this madness. What do you think the square root of x plus 4 squared is going to come out as when you took a square root of a square thing? Agreed? Now, what's the rule about square roots? It has to be positive. So to be absolutely sure, let's be a lawyer. Let's just stick a big absolute value around it to keep everybody happy. Now you notice I stuck a big absolute value around the whole thing and not just the x. And that's the right way to do it, right? Whatever the thing is, it's the whole thing that gets an absolute around it. What about the square root of b squared? Ooh, I'm going to put a plus here, that's for sure. So I have a b squared, take away 10b, add 25. Anybody want to volunteer the factoring of this fella?
Negative
B
5.
minus 5.
We all agree? Good notes. Which, there's a kind of theme happening here. Have you noticed that, yes, you do factor them? Have you noticed that for these questions to work, don't both factors have to be the same? So you always end up with something squared. In this case, you're going to end up with b take away 5 squared, which then becomes that annoying absolute value thing that you have to do with square roots. All right, do you feel comfortable about how you're going to do these kind of questions where the x squared plus 6x plus 9 kind of thing floating around? Feel good with those? Right, so I'll go back now and just continue looking through the homework. And that's how you're going to do question 23, question 24, and question 25. Oh, I'm not going out and in here, but 25 is a stinker. X to the 4 plus 18x squared plus 81. That's a killer to factor, but it can be done. And I do know what the answer is. Anybody want to have a shot at what that ugly thing factors out to be?
The absolute value of x plus 9. Oh, wait, no, that's a negative.
No, I think you said it right. The absolute value of x squared plus 9. Is that what I think I heard they said? Would you agree with that? Right, x squared. Right, isn't 2 9s, 9 times 9, 81? Isn't 9 plus 9, 18? Isn't it just x squared plus 9 times x squared plus 9? Why do we need x squares? Because this darn thing's got an x to the 4 there, doesn't it? Which kind of makes, life a little bit hard. But that was it. And it looks good to me. I think you said x squared plus 9, didn't you? Now, do you need an absolute value round x squared plus 9? Typically, you need it round the some of the other ones, but do you need it round x squared plus 9? Remember, the only reason it's there is make sure everything's positive. Isn't x squared always going to be positive no matter what number you use for x? And then if you add 9 to something that's guaranteed to be positive, doesn't that mean that x squared plus 9 is guaranteed to be positive? So in that case, you don't need the absolute value. Which kind of means you have to take each answer on its own merits. Sometimes you need it, sometimes you don't. If it's a cube root, you never need it, so don't worry about it. But it's square roots, they're the other guy at the party, right? Square roots. Sometimes you need an absolute value, sometimes you don't. At least you've only got 2 shots, right? If it doesn't work with the first one, you know it's going to be the other one. Cube roots, we've done most of them. I'll just pick this one just randomly. What number is the cube root of negative 27? Cube root of negative 27. What number
Negative
is that?
3.
Yeah. They could have tried to throw you here. Couldn't they have put in one of the choices not real? But aren't none of the cube roots ever going to be, that's a double negative, not real, right? So maybe they kind of know that you know that, so they're not going to put it in. Right. Now, I only did square roots of fractions, but you know that we can do cube roots of fractions the same kind of way. So let's imagine that we were doing this one here, right? Don't you do the cube root of 64 on the top and the cube root is 729 in the bottom, and the cube root of 64 is 4. And I do not know what the cube root of 729 is because I've never memorized all the cube roots in the world.
Is it 9?
Yes. If you did that in your head, you deserve a prize. I'm pretty
No,
good at.
I wrote down
You got your cheat sheet. A good thing to have in the final then, right? I mean, you won't get many questions like this, but for the couple of questions you might see, it's handy having that. For us mere humans that don't think ahead like you did and have a nice card handy, I just did it on my calculator, right? And it came up the same way. Can you imagine getting this cube root and even something ridiculously big as that? Wouldn't you just go and let your calculator figure it out for you? Does everybody here know how to get a cube root out of the calculator if it's a TI-84, or do you want to see it? Do you want to see how you get a cube root of a number on your calculator? Okay. If you give me a few seconds, I'll get this thing set up. Now, the way I'm going to show you isn't the only way to do it. I'm just showing you the lazy man's way of doing it. There is a button in the calculator called the cube root button, but it isn't on the front page. I'll call this the front page. It's hidden inside a menu, and by the time you get it, it's not worth the trouble. So this is how you get the cube root of 1728. You go 1728 to the power of, that's what the little thing, you put a bracket around it and you do 1/3. Because a cube root is a fractional power, which is actually what 7/2 is about. Right? Now you hit enter, the answer is 12. Now what about for a negative number? Well, let's suppose you wanted to find the cube root of negative, I'm trying to do 125. Then you type in negative 125, right? To the power of a little bracket, 1 divided by 3. And the answer is negative 5. So as long as the answer is a number, right, a whole number like this, can you see this is going to work out quite well? I mean, technically it'll work for horrible numbers. So if I randomly pick a number like 45 and I wanted to find its cube root, I know that's not going to turn out as a nice answer. But it will be 3.557 to 3 decimal places. And I think, wasn't there a question earlier on where they said, just give me the answer to 3 or 4 decimal places? So that's kind of how you would do it. So, oh, darn it, I've almost, let me show you something else while I've got this calculator floating around here. The square root button exists. It's this button here. It's blue button, that. So I'm going to do the square root. Now, the square root of 81 is fine, right? We know that's a number. We know that's 9. But I'm now going to do the square root of negative 81. Now, we know that's not real. Agreed? So what do you think is going to happen when I hit enter here and I ask the calculator to get the answer to something that's not real?
Say domain error or something like that.
Yep. Not very helpful. I guess it is sort of a helpful. Doesn't it say error not real or non-real? I guess that's another way of saying not real. So you could actually use your calculator to do an awful lot of the numerical questions in this section, couldn't you? But I think it's good math just to know how to do it, you know, in your head kind of thing, or at least quickly. Are things going good? You feel this section's not got too much in it that's weird? Right. Now, if you get cube roots of things, don't you just divide the power by 3? So this one here would be negative 5x. Now, here's a choice. Oh, it's not a choice. Darn it. It says negative 5x here. It could have said, I wish it had, negative 5 absolute x, you know. When you're doing cube roots, you don't have absolutes. You don't need them. So even if I never knew what the answer was, do you see these two here? I know for sure it's none of those two, because cube roots don't need absolute values. The fourth roots need absolute values. Right? Does the fourth root of something, does it need an absolute value at least some of the time? Yes, they do. Do fifth roots need absolute values?
No.
No, right. So if you keep that in mind. Right, so here's a big horrible thing, but basically won't the answer be negative, whatever the cube root of that is x? And now we're moving to, I believe, yeah, we're now moving to the final part and this section will be over. So if you bear with me, you might think, I wonder what's left. Well, not too much. Simplifying expressions with more than one variable. So, square root of 9 x squared y to the 4. Now, if you split it into 3 distinct pieces, that's one way to look at it. Square root of 9 is 3. Square root of x squared is x. Square root of y to the 4 is y squared. Right?
We can't see your,
Uh-oh. Can you see it now?
yeah.
Square
thanks.
root of 9x squared y to the 4. Square root of 9 is 3. Square root of x squared is x. Square root of y to the 4 is y squared. Great. Now, since there is a square root going on here, we have that horrible, do we need an absolute value? And if we do, where should we put it? Right? That kind of question. Does this question need an absolute value around it? How do we tell? Well, here goes. Isn't 3 positive? So don't worry about that. Remember, the whole thing needs to be positive, right? Isn't y squared always going to be positive no matter what number I pick for y? What about x on its own? Could that be negative sometimes? Yeah, I could pick -2 for x. So you want to make this positive? You could do that. Wouldn't that make it positive? Just give everybody the absolute value. Could I do that? Wouldn't that make everything positive? Because the other two are already positive, right? So this is the answer, this is the answer. And they're both correct. Which one do you think I would prefer because it looks prettier? Top one or the bottom one? You think that looks prettier? I like the bottom. I think the bottom looks prettier. That's not a math decision, by the way, because they're both equally correct. So it's not like you lose points. I don't know. That just looks more elegant to me. I don't know why. Evidently, I have no taste. Whatever. We cool with the square roots? How about this square root? You know, I've been sneaky and haven't warned you. You know, normally I say this is a trick question or something. So I'll warn you, this is a trick question. What's the answer to that?
Not real.
Do you know all these x cubes and y squares and z to the 10s and whatever else? And they don't help, do they? A negative inside the square root. So in a way, couldn't you make that root? Couldn't I have made that question this big, right? With every letter in the alphabet, with every power I could possibly think of, and stick a -4 at the front, and wouldn't the answer be it's not real? Let's try cube roots then. Cube root, 3, 9, 27. X cubed, y to the 6, z to the 12. So we're going to take each one of these and figure out what the cube root of it would be. So I'm going to try and find out on its own what the cube root of that would be, what the cube root of this would be, what the cube root of that would be, and finish with what the cube root of that would be. Right, when it's numbers, don't you just go through all the ones and you get 3, right? If you want to find the cube root of a power, the short way of doing it is, don't you just take the power and divide it by the cube root? So 3 divided by 3, that means x to the 1, doesn't it? Now, what would y to the 6 inside the cube root get us? Wouldn't you take the 6 and, you know, divide it, share it, you know, 3 ways? And wouldn't that get you your y squared? What would the last piece get you? The cube root of z to the 12. The cube root of z to the 12.
4?
Yeah. Does this guy need an absolute value around anything? The cube roots need absolute values.
No.
And it doesn't matter how weird the cube root is, the answer's still no. That's final. Nothing else to do. Oh, suppose there was a negative there. Could happen. Wouldn't the answer be almost identical with one extra little piece? Agreed? I'll go overkill. Suppose there's another negative there. What's the net effect going to be now?
Three xy squared
Right.
z to the 4th.
Yeah, just becomes positive. You're comfortable with the negatives and cube roots, kind of, you know, they kind of work well, right? They don't have any weird rules. Square roots are cool in their own way. Right, the last guy in the set then, 4th root. 2, 4, 8, 16. So I'm picking a nice number there, 16. X to the 8, y to the 12. If you break it into the pieces that it's made up from, it's those guys. Fourth root of 16. It's a nice number, isn't it? Any ideas what number would be the fourth root of 16?
Two.
Fourth root of x to the 8.
X
You can
squared.
just, yeah. Fourth root of y to the power of 12.
Y cubed.
It has a kind of flow to it, doesn't it? It's not totally weird. Yeah, square root's half the power. Cube roots, you know, you divide the powers by 3, third the powers, I guess you could call it that. Don't fourth roots just 4 times, and 5 roots you divide it by 5, and who knows what. 10th root, you would just take the powers and divide them by 10. As long as these are nice numbers and they work well with 4, isn't your answer going to look really nice? Later on in the third section, I think it's the third section today, we'll find out what horrible things can happen that make that a little bit trickier. So let's just go back and have a look at the homework questions and we'll be ready for our break.
So that one did not need the absolute value?
Oh, guess who went and picked up a mistake? That last question, which you no longer can see, says 2x squared y cubed. Shouldn't I have asked, does it need absolute values? Which you certainly should have asked. And the question, I guess the answer is, does it then? Does
Yes.
2x squared y cubed need an absolute value? Right, 2 is positive, so it doesn't need it because of the 2. Is x squared always going to be positive, no matter what number x is? Right, 5 squared or minus 5 squared, it's always positive, right? X squares are always positive. What about y cubed? Can that be negative sometimes, depending on the y? Yeah, so that question should have had an absolute value around it. Erica likes the whole thing being an absolute value. Me personally, I just would put it around the y cubed because I think it looks nicer there, but that's just me. So, Brittany, I'm going to take my headphones down and put them near my dog. Listen to this noise. She woke up, she was snoring. Let me show you here. I didn't know dogs could snore until we got ours. Do you have a dog?
Yeah, I have 2.
Oh, that's right.
Yeah,
Where are they?
one is like 12 years old, and then I have like a 1.5-year-old.
Does the 1.5-year-old torment the old girl?
Yeah,
Yeah.
yeah.
The one that's snoring, she's Maggie. I think she's 14 years old.
Yeah.
And Bailey is a bit older. I think Bailey's 4 or 5. And he does torment her.
What type of dog?
She's a rat terrier and Bailey's a Westie.
Oh, okay.
Very cute. What's your dog's?
The old one is a Maltese, and then
They're about this size. They're tiny.
yeah,
Okay.
and then the other one's Maltese, and we think Jack Russell Maltese, but we're not
Can't
quite
imagine
sure.
that. It's got something else apart from Maltese.
I can get him.
Oh, gotcha. Oh, is that cute or what? Oh. I'd pick Maggie up. She's sleeping on the floor beside me, but she's not. The two dogs are totally different. Bailey, he loves, being touched and cuddled and held. And whenever you pick her up, she thinks you're going to hurt her or something. She gets really nervous. She's not happy with it. Oh, and there's the other one. Oh, yes. Yeah. She looks kind of tired, that one. Yeah. Oh, they're cute. Bailey's Westie, but I don't know where he's gone. It's okay. Sorry. There you go. She gets quite twitchy. If I got up and left right now, it's like she would waken up from a deep sleep and think, where am I off to? Because I think she assumes if I move anywhere, there might be food at the end of it. So she's got to just follow me just to make sure. Where's she off to? She's left. Go for it. So how'd you do in the midterm? Was it what you expected?
I think I just kind of overthought it a little bit, but I didn't. But then when I took it, then it wasn't even bad for me personally. Yeah. I feel like it's mainly the homework. You have to put the questions in a certain way on the homework, which gets a little frustrating because it's why is it not working when that's the answer?
Yeah, that's the fault of the software, not the fact that you don't know what you're doing.
Yeah.
So how are things, McKenna? You look tired.
I am tired. I had to move a bunch of furniture last night.
Oh. Your own furniture, or are you helping a friend?
My own furniture. I got a new set of
Red
furniture.
thing. Oh, well. What about you, Hannah? How's things going?
Good. Work
Good.
is tiring.
I think we're all suffering from COVID-19 depression.
Yes,
I mean,
definitely.
we're just, life just doesn't feel the same, and it gets kind of monotonous and repetitive. And that's sad. Every time I get I'm not really kind of person that gets depressed much, but anytime I feel it's getting on top of me, I think of my Vegas trip with my wife that we're coming up for. So when this whole course is finished, me and my wife are going, and it's quite an expedition because we have two dogs, and we don't like putting them in doggy jail, because we could put them in one of the kennels, and she especially, she is not a happy dog. When we get her back, she's it takes you weeks to just, I don't know, she might think that we've left her and never coming back. She'd get that kind of feeling that she's really an agitated dog. So we've given up doing that. So what we've ended up doing is one of my wife's nephews and my sister-in-law are house sitting and sharing. So one of them's doing 5 days and the other's doing 5 days. So we'll be gone for about 9-10 days. And so our dogs, I know, are going to get loved, and they're going to be in the house, and everything's going to be the same because they're used to the people. And that way I won't feel guilty, because I've been on a cruise and I felt really guilty because I saying the dogs are in doggy jail and I knew they didn't like it, and it kind of made me feel like I wasn't a good dog parent or whatever. So now we invest, we invest in members of my wife's family.
Can you quickly just go over when you need the absolute value so I can write it down?
Yeah. Okay, so rules for absolute value. Okay, only use them with square roots, fourth roots, sixth roots. That's the first rule. Second rule, even in these situations, only use them when you need to. So let me give you an example what I mean by that, when you need to. If the answer was 3x, you need it. If the answer was 3x squared, you don't need it. If the answer was x minus 3, you need it. If the answer was x plus 3, you need it. If the answer was 5b to the 4, you don't need it. So why are these two special? Well, isn't x squared always positive? So this is guaranteed to be positive. If it's guaranteed to be positive, you don't need absolute values. Isn't 5b to the 4 guaranteed to be a positive thing no matter what number b is? And if you're not sure, just make the variable -1. And then plug it in. And if the answer is positive, then that means you don't need to worry about it. And if the answer ends up being negative, it means you got an absolute value. So let me just go through these. Let's pick -1. 3 times -1 is -3. Do you see why I need it?
Yeah.
3 times -1 squared is 3 times 1, which is 3. I don't need it, right? 3 is positive. -1 take away 3 is -4. I need it. Right. Unfortunately, that doesn't quite work for this one, but I still need it. Can you imagine I might need a bigger number like -10? -10 add 3 is negative. That's why I need it. And then back to -1 again. So you only use it for square roots, fourth roots, and sixth roots. And even within that situation, you only really need to do it when you have to. And you only have to if the result could be negative for even just one value of x. If there's one number for x you can think of that would make anything here negative, you need to put an absolute value around the whole thing. That makes sense?
Yeah.
So if you're not sure, try a number like -1. I guess if you wanted to be really sure, maybe -10. I picked -1 because it's easy. But you know, -10 might be better because it's bigger.
Yeah.
Okay, everyone. Yeah, it's time. Let's get started. We're on to our second section. Same kind of deal. We'll go through all the permutations of this one. Have a little break at the end because we all need a little break. And then when you come back, we'll have one last section to do, which is section 7.3. And we'll have covered everything that you need for this week. So what's 7.2 dealing with? I think the heading in the textbook is rational exponents. That means fractional powers to us. So, see that little half there? It's called an exponent. Most people would call it a power, right? But that's what it is, right? It's an exponent. So we are looking for numbers or expressions that are raised to a fractional power, like this. So how do we actually solve that problem? Well, we basically use a very nice property that says fractional powers are directly connected to radicals. Right. So, for instance, x to the half is the same thing as finding the square root. Y to the third is the same thing as finding the cube root. Put one more in. Wouldn't b to the 1/5 be equivalent to finding the 5th root of b? Do you see what I'm talking about? That fractional powers are really equivalent to the radicals. So what you do is you take this question and you turn it into a guy that you're much more comfortable with. You turn it into a guy from 7.1. So won't this fella be the square root of 4? Right, a half power, square root. And I know what the square root of 4 is, it's 2. Now, 125 to the power of 1/3, well, won't that be the cube root of 125? Right, 1/3 power cube roots. Okay, we've probably done enough of these that you begin to memorize some of the answers, because there are only so many numbers they can use anyway. What's the cube root of 125 look like? I saw your mouth move, so I'll write it down. It's a 5. Right, a fourth root. Okay, fourth roots are a quarter power, right? Quarter power are fourth roots. That's the guy. The fourth root of negative 16 to the power of a quarter is the fourth root of negative 16, right? What's that equal to, if anything?
Not real.
It's not real. So there's still going to be a few not reals floating about, so be on the lookout for them when they are. Now this fella is the square root of 25x squared. So far so good. Now, doesn't that get you 5? And doesn't this next guy get you an x? We've just finished doing ones like that, right? 5x. When you deal with square roots or fourth roots or sixth roots, don't you have to ask yourself, do I need an absolute value? Do I need an absolute value for this one? I had a shake and a nod. That's bad because I want both to do the same thing. Do you need an absolute value around 5x?
Yes.
You've changed your mind. We all agree now. I see nods everywhere. I'm going for it. Remember the test I said, if you came in early, you would have heard me saying it. Plug in a number like -1. If you get a negative answer, it means you need an absolute value. Right? And you only need to worry about that when you're talking about square roots, that's half powers, fourth roots, that's 1/4 power, and maybe sixth root occasionally as well if they do that to you. Are we comfortable with so far so good? And really, isn't it doing what we've just done, but with one extra step? We're taking the fractional power and writing down what it would look like in terms of radicals, because aren't radicals easier to deal with as a simplification or calculation process? Right, it's just easy to see what you're doing. How about upping the ante then? I'm going to do 81 x squared y to the 4 z to the 10 all to the power of half. Well, that's going to become a square root of this guy. Now, each piece is going to contribute something to the answer, right? So a half power is a square root. Okay, let's zoom through them. Would you agree the square root of 81 is 9? Wouldn't the square root of x squared just get you an x? Wouldn't the square root of y to the 4 half its power and get us what? 2? And won't the square root of z to the 10 half its power and get you 5? Are you comfortable about what I did to each of these terms to get that? Now, to finish with, isn't this a square root? So don't we have to decide, do I need an absolute value? And I see a nod, which is good. Now, why do we need it? Well, would you agree that if x was -1, this would be negative? Wouldn't z to the 5, if that was the only guy that was there, wouldn't it need it? Because wouldn't z to the 5, it could be negative sometimes. And it only needs to be, it could be negative sometimes to make you have to do an absolute value. So you could do that, and I'd probably do that in this case myself. Just give it one big absolute value. Now, I could. Only give it to the two pieces that need it. And would you agree that's the same thing? It just looks different. I see that is correct. I also see this is correct. I kind of, now just to break my own rule about what looks pretty, I think this looks pretty than this one. So you see, sometimes you can change what you think looks nice, right? And by that, I just mean it looks simpler. And simple is kind of the goal. We feel comfortable so far with what we've done? Fractional powers, at least halves, quarters, thirds, at least those seem to transfer into something that we've already seen how to work with. So there are only 20, no, there's not, there's 20, yeah, there's 31 questions here. So let's look at some, see where things are going. Wouldn't the top one there be the cube root of 125? I think I've done that one today. Can I say 5 and you're all happy? Question 2, wouldn't that become the cube root of 8? Question 2, cube root of 8, sometimes called the third root. I call it cube root. Which one of these is the answer to the cube root of 8?
2.
You all feel good about that? Hannah? I like your answer. Wouldn't this fella be the fourth root of 81? I think that one's 3. Tell me if I'm wrong, but I think it's 3. 3, 3, 3, 3, yeah. I'm not doing that one, it's horrible, but I guess you could find it. Oh, I haven't done this one, this is cool. 0 to the power of 1/5. Well, isn't that the 5th root of 0? What's the 5th root of 0?
0.
Yeah. Makes sense? What's the 5th root of 1?
1.
Yeah. Do you know 1 and 0 are kind of interesting? Don't they have very easy answers? Isn't the square root, the cube root, the 10th root of 1, 1? And the square root and the cube root and the 10th root of 0, always 0. So if there's a 1 or a 0 around, your life gets really easy. And I like what they have done in question 7. -8 to the power of 1/3. That becomes the cube root of -8. Right? The cube root of -8. Which is the right answer here?
-2.
Good. Do you know what some of you might have thought? I'm assuming. You might have thought it was not real. But isn't that only true if it was the square root of -8? Cube roots never have a problem, right? Said this before, but the more times you say it, the more it sticks. Won't a cube root always exist? There's no situation, there's no number I can stick inside a cube root. I couldn't get the answer. And I might have to use the calculator to do it because it's a horrible answer, but it exists. And I am going to have to go out and in for question 8 because I have to kind of talk a little bit more about it. In mathematics, brackets are not cosmetic. They are there for a very good reason. Here are 2 calculations that may superficially look like the same calculation and so should have the same answer, but they are not the same calculation. This one has, in brackets, -16 raised to the power of half. This one has -16 raised to the power of half. When I change these into square roots, this one becomes the square root of -16, but this one becomes negative the square root of 16. Do you see the difference? Isn't this one not real? Whereas, isn't this one -4? Do you see the difference a bracket or a not having a bracket can do to one of these fractional power situations? And it's because of a rule called PEMDAS. You ever heard of PEMDAS? It tells you the order that you should do calculations. And what it says is, look, if you see some parenthesis, which I call brackets, but it's the same thing, right? Don't you do that first before you do anything else? And that's kind of why this becomes this and that becomes that. So now we can return back to the questions and we'll see what they look like. Now, suppose I was going to find -16 to the power of 1/4. There are 2 possible things that means. Is it the 4th root of -16, in which case the answer is not real? or is it negative the fourth root of 16? In which case the answer is negative 2. Which is it?
-2.
Yeah. You agree? It's just like the square root one I did a few moments ago. So if you ever see halves, quarter, six, I don't think it'll ever go worse than that, right? Halves, quarter, six. Aren't you going to treat them the same way you do square roots? Right? Because sometimes there's going to be answers where the answer is not real. If you ever see 1/3 or 1/5, that's probably the only two they're going to do. Aren't they fine? You know there's going to be a number somewhere, right? It's going to work somehow, and we are good. This one here is going to be existing. I'm guessing the answer is that one. You can double check it. Okay. Oh, I might not need to go out and in here. Let's see if we can do this without me showing you on the whiteboard. In question 10, it's the fraction 1/36 to the power of half. Won't that become the square root of 1/36? Right? 1/36 to the half is the square root of 1/36. Can we do that, guy? 1/6? Okay, I did too much. I can tell by looking. There's just too much verbal and not enough visual, and not everybody is a verbal learner, right? You only need to say it to them and they can see it. A lot of people, including me, have to see it. So I'll make up some. Suppose you were going to do 4/25 to the power of half. Now, we're using the fact that we know that fractional powers, halves at least, don't they get you square roots? Now, do you recognise this guy from earlier today? Right, a square root of a fraction. Don't you take the square root of the top and the square root of the bottom? And that gets you 2 on the top, and that gets you 5 on the bottom. Right, does it make sense now? That's how you do a fractional power of a fraction. I guess that's a lot of fractions in that. How about -1/8 to the power of a third? Well, won't that be the cube root of -1/8? This is what I do. I know the answer is negative, so I just stick it outside and that's it. I can forget about it. Can't I now separate it into the cube root of 1 over the cube root of 8? And won't that get me -1/2? And as a check, isn't -1/2 times -1/2 times a third -1/2? Doesn't that get you exactly what it needs to, -1/8? So we know it's right. Are we good so far? Right, let's try a couple, give you practice. It's always good. I think 3 should be enough. Column 1, 2, and 3. So we are going to be doing okay, you got a minute to do all 3, because if you know what you're doing, it'll be really quick. Last few things. Okay, here's the first one. Negative 64 to the power of half is the square root of negative 64. What does that get you?
Not real.
I hope every time this happens, it becomes easier and easier to recognize them. And it's just practice. Would you agree the next fella is the cube root of negative 64? What does that get you?
-4.
Agreed. This has got a negative and a square root and a 4 and a 36, right? You see all the pieces where they belong? What does this get you?
-1/3.
Oh, you did better than I thought. You went right to the simplified version. 2/6 becomes a third. Are we comfortable with so far so good what fractional powers are doing? It looks like from the answers I'm getting the correct answer, which is a good sign. Okay, so let's return and look at what the homework questions look like. Okay, so what is wrong? It's okay. Okay, I'm having a dog crisis. It's probably a cat visiting us. And I'm going to take my dogs out and lock them out on the yard where they will be quite happy for the next hour. Okay, come on, let's go. Oh, there you are. Okay. Well, evidently my wife has arrived, so that's a good sign. Where were we? Oh, we're on question 12. Wouldn't that become the square root of 81x squared, x to the 4, right? So this half power becomes the square root of 81x to the 4. The square root of 81 is 9. And the square root of x to the power of 4, that gets you, oops, damn it, I did it too early. That gets you x. I think I hit that. Squared. Okay, what's going on? Hit it. There we go. Squared. Okay, so square root. Do I need an absolute value or not? Does 9x squared need an absolute value around it? Can it ever be negative?
No.
So it doesn't need one. Right, if you plug in a number like -1, won't 9x squared just be positive? Right. Now, if it was 9x, it would need an absolute value, but not when it's 9x squared. Right. Do you need me to go through any of these questions here from 13 to 16? Because I'm not quite sure which ones look good to you and which ones look weird. So 13 to 16, is there anything in that bunch that you're thinking, I'm not sure what I need to do here? You know, you are allowed to ask. Silence is not a good idea. Is there anything in this bunch that you need to ask about? Because if you don't, you're going to be stuck with it in the homework.
14.
Okay.
I mean, I think that's going to be a simple answer, but
Hey, better be safe than sorry, agreed, right? If you look at this, this is a weird fraction. Occasionally they throw a weird one in. Wouldn't this be the 9th root of x to the 9? The 9th root, right? What do you get if you take x to the 9 and you divide it equally amongst 9 things? Don't you just get x to the 1, which is x? So
Okay.
so your question was, it's probably a nice easy answer. I agree with you. I think x is a nice easy answer. I guess I should also check, do I need an absolute value around this fella? Well, it came from the 9th root of something. Cube roots, 5th roots, 7th roots, 9th roots, and all the other ones that look like that, they do not need ever absolute values, remember? Odd roots don't need absolute values. So the answer is x. That's it. Anything else in that bunch? Right, I'm going to jump straight to question 16. And then I'm going to go off a little bit and do some on the whiteboard, the paper. What's the answer to 16? And I don't need to do any work. I can just tell by looking at it.
Not real.
Great. Isn't a half power going to be a square root? Right, half powers are square roots. Isn't the square root of negative 36? I can stop there. I don't care what the rest is going to say. Isn't the square root of negative 36 something not real? The square root of negative 4 something, the square root of negative 9 something. The minute you see a square root with a negative inside, is kind of, that's it, isn't it? It's kind of the end of the question. Not real. I'm going to do 17 and some other ones kind of sort of like that in whiteboard. Here we go. And let's look at this guy. Negative 27 b cubed raised to power a third. That's going to be the cube root of negative 27 b cubed. If you want to see what some working might look like, you're allowed to separate them into 2 distinct cube roots. Won't this guy get you negative 3? What's the cube root of b cubed going to get me? The cube root of b cubed.
Just B, right?
Just b. Now, do I need an absolute value around this question? Correct. Shaking heads is correct. Don't cube roots never need absolute values? Okay. We go with that. Now we're going to move on to more awkward fractions. What could that mean? Well, how about 8 to the power of 2/3? We've done 1/3 and halves and quarters, right? But we haven't done 2/3 and 3/4 and 4/5, right? And for want of a better word, fractions, just general fractions, right? So we have to have a method for figuring out what these are equal to. Now, if it had been 1/3, would it not have been the cube root of 8? Great. So we're going to use the fact that this is the same thing as that. So you can get 8 to the 2/3 by finding the cube root of 8 squared. Or you can get the cube root of 8 and then square it. So let's look at what you get in both these situations. Right. If you go this way, it's the cube root of 64. Can you trust me that that's 4? If I go this way, what number is the cube root of 8?
2.
And won't 2 squared get you 4? Do you see that both ways of looking at this fractional expression, both ways end up being the same answer? So aren't these the equivalent? In other words, you can do it one way or you could do it another. Of the two ways that I've written it, which one looks more sensible to your brain? Do you like this method? Or do you prefer that one? Right. I get nods on this one. Any nods on that one? Where you do the cube root first and square the answer later. No? Okay. Do you know it doesn't matter? It really doesn't. Won't you end up with 4 when you're finished? So, how about 4x squared to the 3/2? Okay, there's a 2 and there's a 3. One of these two is going to be used here. Is it going to be a square root or a cube root for this fraction? And how do we know which? Because it's not a good idea to guess. 3/2 power. Is it going to be a square root or is it going to be a cube root?
Square.
Okay, which means that guy is cubed. Or square root of 4x squared, still a square root, and cubed. So I guess the question, and it's true here as well, when I look at these two questions and I'm trying to think to myself, which one of these two is easier in my brain? And maybe I'm the only one that thinks that. I think this one is easier to do. Now, if you think this one is easier to do, then do it, because it'll be the right answer. You know, it's both going to work, right? So it's not like one method's right and the other's wrong. They both are going to work. I'm going to try and sell this method. Isn't the square root of 4 2? Isn't the square root of x squared x? You agree? And then you put a big bracket around it and you cube it. Now, when you cube something, doesn't that mean you go 2x times 2x times 2x, and you're going to get 8x cubed? You happy with that answer? Right, 8x cubed. Right, let's go the other road. If you do 4x squared, 4x squared cubed, don't you have to do, and over here, don't you have to do 4x cubed times 4x cubed times 4x cubed, and 4, that gets me 64, and doesn't that get me, what am I saying, cubed, 4x squared, my apologies. It gets you 64x to the 6, so you go 64x to the 6, and isn't the square root of 64 8, and the square root of x to the 6 x cubed? Do you see you end up at the same destination? I don't know. I'm the only one here. That's fine. I like this because it seems less work, but maybe you don't. Maybe you think this is less work. And I've forgotten to ask my question. No matter how you look at it, these are square roots, aren't they? Both of them. Does this answer need an absolute value? Does 8x cubed need an absolute value? I see one nod and nothing else.
Yes.
Agreed. Why?
Because it could be negative.
Do you know my little test? Make x -1 and check it out. See if you find 8x cubed when x is -1. Don't you get 8x cubed? Don't you get 8 times -1 cubed? Don't you get 8 times -1? Do you see the answer is negative? Since the answer is negative or could be negative, you need an absolute value to make sure that you're safe. These are more difficult, right? This is the end of the line, right? This is what you kind of have to deal with at the end. Are we feeling, do you want me to do some more before we look at the homework in the book? Would you like to see some more? Okay, so let's do some with a cube root in it. Okay, so 8, I'll put a negative in there. I'll do an x and I'll do a y squared. Right, let's go crazy. Can I do that? No, I can't. Make that x cubed and x to 6. Now I can do it. And we'll do a 2/3. Now, whatever is on the bottom tells you what kind of radical you're going to have. 3 in the bottom means it's a cube root. So it's going to be -8x cubed y to the 6. Great. What's that 2 going to do? How does that get incorporated into this? How does that 2 get used?
So that squares the entire thing.
Right, so are you happy about squaring it that way? Because that's the way my brain works. Could I square the inside? Yep, wouldn't both be okay? So I'm going to do it this way because I don't want to keep doing every question 2 different ways. But if you're doing it as your own notes, you might have decided this thing inside could get squared. So let's see what we get here. The cube root of that is -2. The cube root of that is x. And the cube root of that is y squared. And then you square it. And if you take this guy and you square it, you're essentially just multiplying it by itself. And that gets you a +4 and x squared and a y to the 4. Now this question came from a cube root, right? Right here it's a cube root. When it's a cube root or a 5th root, you don't worry about absolute value, so you're finished. Right, that's the final answer. Are we good? As good as we're going to be, right? Okay, let me go and see what we have in store in the homework. There's an 8th power. There's a 5th power. There's a, what would that be? That would be the square root of 25 cubed. That would be the cube root of 27 squared. Oh, let's try this one because there's choices. 64 to the power of 2/3. Wouldn't that be the cube root of 64 squared? Right, so you find the cube root of 64 and then you square your answer. What is the cube root of 64? I see 4. You agree? 4? Square root is 8, but the cube root is 4. And then what do? You square it. So 4 squared, 16. That would have been the answer. This guy here, if you write it out in full, it's going to be the square root of 144, then you cube it, which is some ridiculously big number, so use your calculator. Oh, I think I should do a fraction. So I'm going to zoom out in a minute, and we're going to do 4/81. And it's raised to the power of 3/2. The 2 on the bottom means it's a square root of 4/81, and the cube, oops, means cube the answer. So that tends to be the order I like to do these things, right? Square roots first, cube it last. Okay, let's see if we can speed this up. We've done a couple of these. Isn't it relatively easy to get the square root of a fraction? Don't you just get the square root at the top and the bottom? Okay, top is 4, square root gets you 2. Square root of 81. What number is that?
9.
9. And you're going to have to trust me on this one. 2 times 2 times 2 gets you 8. 9 times 9 is 81, times another 9 is 729. Or you go hitting for your calculator and pressing buttons. Are we feeling comfortable about fractional powers that aren't like halves and thirds, but things like 3 halves and 5 quarters and who knows what else? You feel comfortable about the process? Okay, let's return back to the homework then, because I think we're getting well on our way to getting this done. I've already covered examples like 28, 29. I guess I should finish with 31. So in question 31, it's negative 216, x to the 6, y cubed, all raised to the 2/3. So this is going to be the end of this section. And we'll take another break. Okay. 2/3. Square root or cube root? Two-thirds, cube root. I see your mouth moving and it looks like you're saying cube root, right? Inside is going to go negative 216, x to the 6, y cubed, and the whole thing is squared. I'm doing it the order that makes most sense to me, right? I think this is less work. It's okay to have negative cube roots. Doesn't that just mean the answer is negative? Okay. Oh God, that's a hard one. Oh no, I know the answer. Cube root of 216. It's not that big a number. Cube root of 216.
6.
Yeah. Cube root of x to the 6. Don't you just divide the power by, 3. Cube root gets you 3. And won't y cubed just get you y? So you're happy about that 6. The cube root of that is this. And I just made a mistake. Can anybody see my mistake? Is the cube root that guy? No.
2.
It's 2. I said it, but I didn't do it, right? So I'm going to take negative 6 x squared y and multiply it by negative 6 x squared y, which gives me positive 36 x to the 4 y squared. Now, this question is a cube root, so I don't worry about absolute values because we don't need them. Okay, I think we're just going to get started now. Hopefully Brittany and Mary will hear me talking and they'll get here. There you are. Yeah. I wish this had been in the first hour because there are going to be some challenges on this last section and it's much easier to understand something when your mind is fresh rather than when you've already done 2 hours, which is a lot to take in. But, you know, that's the world that we live in, so we have to do it. So what's 7.3 dealing with? Well, we're going to look at simplifying square roots, and I've called them complex square roots. Really what we're going to be dealing with are square roots that don't come out nice. Square root of 36 comes out nice, right? The answer is 6. But not every square root in the universe comes out nice, right? In fact, the majority of them don't. So there are two approaches to it. One is you just go to your calculator and write down 12.3456, and we're not going to do that. The alternate is there a way of at least writing a square root in what we would call a simplified form? And the answer is yes, there is. So show you a nice square root first. Let's do 4. Couldn't get much nicer than that. The square root of 4 is 2. So what about the square root of 20? Well, this is an example of a complex square root. Would you agree that there is no nice number that when you multiply it by itself, you get 20? There's some horrible decimal, but there isn't a nice number. And we don't want the horrible decimal, so we'll ignore it. So what's the alternative? What's the compromise? Well, what you need to do in this question and the ones that come later is that you need to find two numbers that multiply together that give you 20. And one of these two numbers has to be what's called a perfect square. Now, I'll write over here the perfect squares. 1, which is there only because I want the first number. 1, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 48, 12, 169. I'll stop there, but obviously you could go further, but hopefully we don't need to. So I need to find two numbers, one of which has to be a perfect square. That means one of these has to come from this list. Which one should I choose then? Out of this entire list of numbers, which one can give me 20?
4.
Right. Agreed? So stage 1 is rewrite your number, in this case 20, as two numbers, one with a perfect square, right, and the other just what's left over. You then separate it out into two individual square roots. Now, do we know what the square root of 4 is? Yes, we chose it because it was a nice number. And that guy might not look like it to you, but that guy is the simplified version of this guy. What simplified means in mathematics is that you used a smaller square root than the original. Would you agree this is using the square root of 5 and this was using the square root of 20? And one of the reasons why this is helpful is that if you have a number of square roots and they all look different from each other, if you simplify them, it may end up that they all are multiples of the same square root, right? So they're all different versions of the square root of 5, which allows you to add them all together. Let's try another one. Suppose I was wanting to do, let's find out, square root of 48. So it's like a 3-stage process. Stage 1. I need two numbers that multiply together that give me 48, and one of them has to come from the perfect squares. Any candidates? Any numbers that you can see that would work with 48? I can see two choices.
4.
Great. And if I did 4, it would be 4 times 12. There is a second choice that also works, isn't there? One of these numbers times something else should get you 48.
16 and 3.
And it would be nice, but not true, if I would just say, it doesn't matter, whichever one you get, it's good. And that's not true, unfortunately. When there is more than one choice, you pick that one. You pick the one that uses the largest perfect square. Because if I choose this one, do you see that I can't get any better than 4 root 3? If I choose this one, wouldn't I get 2 times the square root of 12? But couldn't the square root of 12 simplify as 4 times 3, and and so on? So the rules of this game are quite messy. You need to find 2 numbers, one of which must be a perfect square. And the second part of that rule is, if you've got more than one choice, you must always pick the biggest perfect square. And as long as you follow those rules, you will be able to simplify any square root. In this case, that guy gets you this. So far, so good? Okay. Let's try and simplify the square root of 200. Oops, found my mind up. Here's my perfect squares. Who are we going to use this time?
$102.
Yeah. This might or might not help you. It's a good idea just to have this at a piece of paper somewhere. And this is how my brain works. I start here and I keep going up until I get one that works, right? And if I get one that works, isn't that the one I want? Because it's going to be the biggest. If you start from the top down, do you know that you have a temptation to stop too early? Couldn't I have done 4 times 50? And if I went a bit further, couldn't I do 25 times 8? And then I might not bother to look any further. But if you start at the bottom, the first one you hit is the one you should use. Now, in this case, the square root of 100 times the square root of 2, and you get 10 root 2. That's what we mean by the simplified version of this. And in a way, it is kind of simpler. Would you agree? The square root of 200 is a really big number. And isn't 10 root 2 a kind of prettier number? It's kind of smaller. And especially it's using a smaller square root. I'm just going to give you one to have a shot at. So give me a minute to figure out some number that's going to work. Shooting heckin' spice in one. Simplify the square root of 167. Oh, shooting space, I'm getting tired. Now you can do it. Do you know which number I picked, which perfect square I used in this question? Even though I had to change it because I screwed up later. What one works with 147? I hope it works with 147. Yeah, it does. Nobody found it?
49 and 3.
Okay. Here's my calculator. Especially this time of night, I'm not great at dividing. So let's give you a strategy for finding this guy. You know it has to come from this list. Start at the bottom, work your way up. Right, do you know I'm not even going to try 169 because it's too big, right? Would you agree that one isn't worth trying? So I'll start at this guy. If you go 147 and you divide it by 121, you see it's an ugly answer, so that doesn't work. If I tried 147 and I divide it by 100, although I could have done that in my head, it still doesn't work. If I go 147 and then I divide it by 81, it still doesn't work. Now, this is a laborious way, but isn't this at least going to work? I mean, if you hang in there, it's going to work. So I'm going to do 147 and divide it by the perfect square 64. It doesn't work. And then we get to 147 divided by 49, and you see it works. isn't that the only one that goes in an exact whole amount of times? In this case, 3 times, which tells me 49 times 3. So do you see the calculator and the perfect squares working together can do even the ugliest looking number that you could possibly think of, and it would still work. Now, once we've done that, we recognize that it splits as a square root of 49 times the square root of 3, and the square root of 49 is 7. And you got 7 root 3. Are we comfortable then with square roots of numbers that aren't pretty? Okay. Then I'm going to stick to square roots and just add an extra level. Suppose I wanted to do the square root of 40 x squared. Right? Simplify square root of 40 x squared. Now, I would split that into its 2 pieces. Like that. Won't this guy just get me x and that's it over with? Right, square root of 40. You could either keep the work in here or do it in scratch paper. What 2 numbers give you the square root of 40? And one of them must come from here. Square root of 40. One of them must be a perfect square. Okay, I see your lips moving, looks like 4. Is that what you were saying? So 4 times 10. Which gives us 2 root 10 with an x. Does this question need an absolute value? It's a square root, isn't it? So it is a valid question. It might not. 2 is positive. Square root of 10 is positive. Could x on its own sometimes give you a negative answer? If I said x was -1, would I get a negative answer out of this?
Yes.
Right. And because of that, you can have that. Me personally, I think that looks prettier, right? So you can do 90% of it right, and when it's a square root, couldn't you just forget the absolute value thing and the computer says, hey, you got it wrong, and you don't even see why you're wrong because it looks perfectly correct, because 90% of it is perfectly correct. Now, if that wasn't bad enough, and we're focusing just right now on doing square roots, and then after this we'll talk about cube roots, and then lastly we'll talk about combining 2 things together. If I asked you to get the square root of x squared, wouldn't the answer be x? Well, technically, absolute x. That's fine. If I asked you to do the square root of that guy, wouldn't the answer be x squared? Do I need an absolute value around x squared? Good, I'll take a shaking of a head. Oops, where are we? Stop for a second. Darn it. I was trying to unmute you all in case hitting the space bar was becoming too much of a challenge, because I've got a feeling that I'm teaching on my own here and it's depressing. And I know I'm not, but it's depressing. Okay, is there any way for me to undo this? Probably not, in which case I should just give up. Okay, well, let's just continue with our questions. This guy does not need absolute value, this guy does. Why is this one not needed, but that one did? Well, isn't x squared always going to be positive? That's why. Well, you might think, what's the big deal? We've done that. This is the big deal. What you're going to do to simplify x cubed. When it's 2, 4, 6, 8, 10, things work really well, don't they? But when it's x cubed, not so nice. I'm going to do something that looks a little bit artificial, but it works. Isn't x cubed x squared times another x? Isn't that just a different way of writing x cubed? Great. Now, just like I did with the numbers, can't I separate this out into the square root of x squared times the square root of x? But won't the square root of x squared become x square root of x? And although you might not think it, that is the simplified version. We've reduced the x cubed to an x, so therefore it's a smaller square root. Okay, let's try another version of that last process. Suppose I had y to the 5, a square root of y to the 5. That's going to split as a 4 and a 1, right? That's going to become the square root of 4 times the square root of y. And won't the square root of y to the 4, well, you tell me, what does the square root of y to the 4 get you?
Y squared.
So can you see we got that guy? Does this guy need an absolute value? That's always positive because it's a square root, so that's the answer is no. Now, to finish, the ultimate version of this process, where I'm going to stick everything that's ugly in one place. So I'm going to have as my number 98. I'm going to have an x to the 4, and I'm going to have a y cubed. And the ultimate horrible thing is just a z. And our job is to simplify this. If you can simplify this one, you'll be able to simplify any square root you're likely to see. Stage 1, I am going to separate all of these terms into their individual bits. And then I just work on each one separately. And at the end, we'll put the mess together. So that's the strategy for these ugly, extra ugly square roots. Break them into their separate bits, their separate square roots, and then work on each one separately. So I'm going to have to, I don't know how I'm going to do this. Oh, I could do this, right? Let's look at how to deal with that guy. Don't I need two numbers, one of which must be a perfect square? That gives you 98. Which guy does a 98?
$49.
And if I can skip a little line here, won't that eventually get you 7 root 2? You know, once you get used to it, you don't have to write every line, right? So this guy here is 7 root 2. That's good. Okay, next fella. This one's quite easy. Would you agree that the square root of x to the 4 comes out without too much thinking? Agreed? What power of x do you get when you take the square root of x to the 4?
X squared.
Oops. Oh, not so pretty. Don't you have to deal with things like y cubed, y5, y7, right? Those ugly guys. Don't we have to deal with them a little bit more carefully? Now, when I take this guy, don't you split it as a y squared times a y? That's how you take care of y cubed. If it was y to the power of 5, wouldn't I split it as y to the 4 times a y, right? So an even power, and then what's left? This becomes y, and this becomes square root of y. So we now have y square root of y. And it's kind of a trick question. can you actually simplify the square root of z? Can you do anything to it to make it better? No, it's a kind of leftover orphan. So you just write down square root of z. So each of the bits gets split. Each of the pieces gets simplified on its own. And then you have to put the package together. So let's see what happens. I got a 7. I have an x squared. And I have a y. So I put all the things that don't have square roots. And then right next door to them, I tag on all the things that do have square roots. In this case, there's 3 of them. And you might have thought that that was the end of the answer, but there's one more thing we can do. Do you think there's a way that we can take these 3 things and put them together as one thing? And the one thing is that one thing. Does that make sense? So right now, we've done 1/3 of what we need to be able to do. If I give you a really ugly square root, hopefully you should be able to simplify it, right? Using the kind of tricks that we've done. So I'm going to go and have a look at the homework questions and see if what we've done kind of suits the thing. Now, I may have to jump around a little bit because the book kind of jumbles up the questions. So I'll skip by ones that we don't know how to do yet. Would you be comfortable in simplifying question 1? The square root is 75. Would you be okay with that one? Yeah. Would you be okay with the square root of 20 and the square root of 8? I'm not doing cube roots because we haven't talked about them yet. So I'm just skipping by this. The next question you should be able to do is simplify the square root of 75a squared. And we've done ones like that, agreed? We're cool with that one. Question 8, question 9 are very similar. Isn't question 10 like that ugly one I just did last? It's got a square root, it's got 128a cubed and b to the 5. 11 is a pretty ugly version of that. So is 12. Skipping by the cube root guys. I'll let you figure out the 4th roots, but they're very similar, and so is the 5th. And then simplify the square root of 40. That's back to straightforward. 18, pretty good. Oh God, 363. What a heck of a number. Oh, I got it. Square root of 363. Give me the perfect square that uses 363. I got a moment of inspiration and I got the number. 363. Who does he work with? It's a big one. It's a big number. And it was on my list of perfect squares.
121 and 3.
Times 3. So you're going to end up with 11 root 3. So even something ridiculous like that, you could get it. 20 is just square roots of things. Forget the cube roots. Oh. I don't need to worry about them yet. They come later. Let's move out of here and do cube roots. And once we've done cube roots, the last one is all the other stuff, right? Which means pretty much anything that they want to throw at us. So the only good news I can have you is that when you do simplify cube roots, it's the same process as simplify square roots.
If you're writing, we can't see it.
I am writing and you're correct. I forgot to go back in. Thank you. Here we go. Now, perfect cubes. 1 times 1 times 1. I put that in for completeness. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. You probably won't need anything else because that's pretty big, right? So there's a lot less choices in cube roots. So I guess that does make your life a little bit easier. And we'll start with numbers and then work our way up, right? So if I was being asked to simplify the cube root of 16, Now, the square root of 16 is 4, but it's not square root, it's a cube root, right? So it's not going to come out nice. You need two numbers that multiply together, and they have to be, one of them has to be the perfect cube. Can you see which number we're going to use this time? Would you agree that it's 8 times 2? Would you also agree that this process is pretty much the same process as the square root? So we could probably do it a lot quicker, right? Yeah, I don't need to do it like you've never seen it before. Right, if you break it into its two component pieces, don't you get the cube root of 8 times the cube root of 2? But the cube root of 8 is a number, in this case, that number. Try the next one, move up. What am I going to pick? Oh, and I'll stick a negative in. I haven't done negatives for a while. Since that's a negative, can I just stick the negative outside? Because I know the answer is going to be negative. That way it's done. I can forget about it now. I need two numbers multiplied together, and one of them has to be a perfect cube. And I've forgotten which question I picked it from. It must be 27. Let me check. I better make sure that I've given you one that works, or that wouldn't be fair. Okay, I've got it. What perfect square works with 243? There's not a lot of choices, agreed? Which one works with 243?
$27.
Right. And I believe it's 27 times 9, but you can check that later. If I know that it has to be one of these numbers, which I kind of do, why would I have picked 27 without even thinking about it? Well, would you agree that 125 is a non-starter? Because see if 125 works, doesn't the only thing 125 work with is numbers that end in 0 and numbers that end in 5? Right. I'm going to kick out 64 and 8, even though I don't need to check them. Because if you use 64 and 8, don't they only work with even numbers? Because 64 times something is even and 8 times something is even. So just basically a process of elimination, I know it's 27. So negative the cube root of 27 multiplied by the cube root of 9, and that guy's 3. So there's your answer. Now the only thing I need to do now is put powers in here, and that's pretty much that situation covered. Great. So the cube root of y to the 6 is y squared, and the cube root of y to the 9 is y cubed. So what the heck do you do with the cube root of y to the 7? Well, don't we kind of do the same trick that we did with square roots? I break y to the 7 into two pieces, but doesn't one of them have to be a multiple of 3? So it has to be a y cubed or a y6 or a y to the 9. In this case, it's going to be y to the 6 times a y. So yeah, you break them into two things multiplied, but one of them, the first one, has to be a power that's a multiple of 3, right? It has to be y cubed, y6, y9. And the reason for that is that when I split it up here, isn't this going to come out nice? And the bit that's left over is just going to be the bit that's left over. And there's your answer. So what do you think you might do with y to the 8? Well, don't you still have to split it? But this time as a y to the 6 and a y squared, right? It has to add up to 8. I can't do a y7 or a y5 because remember the first thing has to be a nice power of y, right? It has to be y cubed, y6, y9. It has to be a multiple of 3. And if I break this fella up, I now get this guy, and this fella is y squared, and this one gets you that guy. So the simplified version of this is y squared times the cube root of y squared. You look puzzled, or are you just tired?
Wouldn't it just be y squared since it's y to the 8?
Would it be y squared since it's y to the 8? Well, this is a cube root of y to the 8, so I'm trying to say where you are. You happy with this line? That's not your issue. If you break this into a cube root, you happy that this is y squared? So I'm trying to think of what you're thinking I've done wrong.
6 times 2 is 12.
Oh yeah, but when you multiply powers together, don't you add the powers, not multiply them?
Oh,
Is that what your issue was?
Well, isn't 2 times 2 times 2 8? So it just would be y squared.
It would be if you were doing numbers, but isn't y squared times y squared times y squared y to the
Just 8.
6?
Okay. Okay. There we go. I got it.
If I'd asked you that question in the first half hour, it wouldn't have been an issue, right? We're all getting tired. We'll just have to bar our way through. So all I'm going to do now is put the whole package together and do one of the horrible ones. And then the last bit, right, that'll be this 2/3 of this is done, right? The last bit will be all the other ugly bits that we haven't done. So here it goes. So I am going to pick a number from here. It's kind of hard. There's not many choices. So I'm going to go 250 x cubed. I don't know why I picked y. Y to the 10 z. And so our job is to simplify that fella. Well, I'm going to break it into its component pieces. The cube root of 250, the cube root of x cubed, the cube root of y to the 10, and finally the cube root of z. Isn't it kind of very like the thing we did with the big ugly square root, right? You don't try and do it in one go, you try and break it into manageable chunks and deal with them that way. Okay, so let's start with 250. It's going to have to split, isn't it? Two numbers that give you 250. One of them must be this perfect square from here, right? I think this one's a little bit easier to see, would you agree? Which one would I be choosing then?
125.
Okay, times 2. Won't that get you the cube root of 125 times the cube root of 2? And the cube root of 125 is 5. So that's the first piece done, right? Let's move on to the second piece. Oh, we got lucky here. What's the cube root of x cubed? Don't overthink it. Cube root of x cubed.
X.
Yeah. So can't I just go straight to the end and just write x? I don't need to keep, doing much. Let's leave this one for a minute. What's the cube root of z? Can we do anything to it? Or is that as good as it's going to get? Agreed? So I kept kind of the guy that's going to cause us the most trouble. What I think is going to cause us the most trouble is y to the 10. Now you got to split it as a power of y times another power, right? And remember, when you multiply powers together, you add the exponents, right? So how am I going to split y to the 10? It has to be multiples of 3, right? Y cubed, y6, y9, and so on, right? How's it going to split?
9 and 1.
Okay. And that's going to become the cube root of y to the 9 times the cube root of y. And isn't the cube root of y to the 9 y cubed? Cube root of y. Now, if I take all the pieces, I've got a 5, I have an x, I have a y cubed. If I tag all the cube root pieces next to it, we get these 3 guys, which we can combine into one big cube root, and finished. Are we cool? Right, to save time, I'm not going to go back to the homework questions and just show you some examples of that, but if you go, you'll be able to see them. There'll be things that look something like this, and this is how you would simplify them. So we're on to our final step, and that is all the other stuff that's left, right? All the other complicated radicals that you can have. So suppose I have to simplify this guy. You want to simplify this guy. Wouldn't the first thing that would be useful is to make it nicer? In this case, it works really nice. This particular case. Now, do you recognize that this is basically 2 numbers multiplied together? One of them has to be a perfect square. What 2 numbers work with 90? If it helps, oh.
10 and 9.
Oh, good. I was going to bring this out, but you beat me to it. 10 and 9. I would call it 9 and 10, but it's too late now. It's the same thing. Square root of 9 gets you 3. Square root of 10. You've now finished that question. How about the square root of 72 over the square root of 3? That's a little different. And there's quite a lot of things, different things going on here. Square root of 72 over square root of 3. Any ideas of making this easier in some way or other, putting it together in a different order, whatever?
Square root of 72 divided by 3.
I like that thinking. I believe that gets you the square root of 24. There, took a while, but my brain finally got it. We're almost there. Can we do something with the square root of 24 to make it nicer? Not a lot, but we can do something, can't we? Can you think of any number in the perfect squares that works with 24? Because I can think of just one that works. Something that works. 2 things multiplied together that give me 24. Something that works with 24.
4 and 6.
Yeah, nailed it. And won't that get me 2 root 6? And we solved that question. So can you see that you just have to, it's not one method here, isn't it, really? You know, figure out what you've got and deal with it, right? Just try and figure some way of making it happen, right? Let's, still in the fraction theme. Just making up a random ugly question. Anything you could do with this guy? Well, I've got 2x cubed y squared on the top, and I've got 8xy on the bottom. Is there anything that can cancel, anything that can simplify? I'm thinking along those lines.
1 over 4.
Okay, so we'll cancel the 2 and the 8 and get a 4, so I like that, that's a good start. Can the x cubed on the top cancel out one of the x's in the bottom? Agreed? And that would leave me what, an x squared on the top? Can the y squared and the y, can they cancel a little bit? Yeah. If you cancel a y squared on the top with a y in the bottom, don't you leave a y left on the top? So I'm looking at this guy, right? And sometimes that's the end, but not this time. I can split this into three pieces. Great. Wouldn't the bottom piece be a 2? What about the square root of x squared? X. Now, at this point, you're finished. And the reason I know I'm finished is there is nothing in the world I can do to that. Would you agree that it's kind of done to the point where there's nothing left to do to it, right? You can't do anything with square root of y, right? You can't really do anything with the other two pieces. That's how I know that's finished. You might say, well, how do I know that I'm not finished here? Well, my brain says, look, isn't the square root of 4 going to turn into something? Isn't the square root of x squared going to turn into something? I know it's going to change, right? I know I've not finished. But when I get to this stage, would you agree I'm finished? There's nothing I can say to do to that that would change it in any way that's meaningful. We're getting pretty close to everything I can think of. I'm sure there's some I haven't thought of. We've not even looked at this as a possibility, but you know, you can simplify this. Isn't there a thing in algebra that says you're allowed to collect like terms? Now, normally the like terms are 5x, add 2x, add 3x, you know, they're all x's. Or 5a plus 2a minus 3a, right? They're all a's. But do you know the rule doesn't care what you are as long as you're the same what you are? Would you agree these are all root x's of various amounts? So I've got 3 of them, and I add 5. What would that be? 8 of them. And then I take away 2. That would be 6 of them. In a funny sort of a way, I think that's easier to do than some of the other stuff, isn't it? Agree? How about this fella? The square root of 20x plus the square root of 5x, take away this guy. And this is going to be my last question. After this, I'm just going to go and have a look at the homework and see if there's anything I need to talk about, and we'll be finished for today. So you deserve a prize for making it this far. Well done. So just hang in for the next 5-10 minutes and we are done. These guys cannot be added together because they are not the same square root. Isn't this got 20 in it, this has got 5 in it, and this has got 45 in it, agreed? So we should, if we work at it, maybe make it work. So let's take this fella here. If I split it up, isn't it the square root of 20 times, oops, the square root of x? Can you simplify the square root of 20? Here's my little guy. Can you simplify the square root of 20? Can you use one of these numbers with 20?
4.
Right. So that's going to be 4 times 5. Isn't that going to be the 2, the square root of 5 times the square root of x? And then won't that turn into 2 times the square root of 5x? Are you happy about this one guy became that guy? Now, would you agree that the square root of 5x, you can't do anything to it? That's as good as it's ever going to be. And now I'm going to take away this guy. Well, this guy can be split as the square root of 45 times the square root of x. Now, can 45 use one of these guys? Can I simplify 9? 9 times 5, agreed? And that's going to get me, what's that going to get me? That's going to give me 3 root 5 times root x. And isn't that going to get me 3 square roots of 5x? Now, the original horrible mess couldn't do anything to make them simpler, right? Couldn't combine them because they were all different square roots. But in this new world, aren't they all different amounts of the square root of 5x? Which means that they are similar and can be added and subtracted. So similar terms, here we go. 2 of these guys, add 1 of these guys, gets you 3. 3 of these guys, take away 3 of these guys. What does that get you? None. Do you think you write 0 square root of 5x, or do you think mathematicians would just write 0? Because one of them is the form that you should write down. 2 add 1 is 3, take away 3, 0.
Wouldn't it be
0?
negative?
No. 2 plus 1 is positive 3, take away 3, cancels out, you get 0.
Oh, there's a 1 there.
Yeah, there's a 1 there technically. There's one of these, but you never write it. 0 or 0 root 5x? That's my question. What do you think mathematicians consider the right version of that answer?
0.
Yeah. Isn't there a rule in math that 0x is just called 0, or 0a is called 0? That's the rule we're using. Isn't there another rule? Isn't 1x just called x? And isn't 1 root 5x just called root 5x? So that's why there was 1 there. Okay, let's have a look at the homework and we'll hopefully get enough help to finish, to let you be able to finish it. So, okay, there's combinations out here all over the place. Okay, I don't think I've done 24, but we could have a shot at it. Suppose you were doing question 24. You would split this guy into 3 pieces. Wouldn't you call it the square root of z squared on the top, the square root of 4 and the square root of x squared on the bottom? If you did that, wouldn't the answer just be z on the top and 2x on the bottom? Right? Because you're not going to see the same question twice. You see they're all kind of weird and wonderful and different, and you just have to deal with it.